Now let's move to the user case 1, which is focusing on the assessment of changes in the build-up areas with the global human settlements layer. Before moving into the hands-on exercise, let's have a look at the dataset. So the dataset is based on Landsat data and provides high-resolution information on build-up presence and the changes for several time steps, so starting from 75 till 2014. And it is based on not only at satellite imagery, but also census data and crowdsourced and volunteer geographic information, and provides the data globally at several time steps. So now let's shift to the Earth Engine API, where we will have the hands-on example with the dataset. So here we can see the Earth Engine code editor, and in order to start the analysis, first we have to import the dataset. There are two options for importing the dataset. Either we can import it using the unique ID associated with the dataset, or we can use the code editor search tool to find the dataset. In the search tool, if we put some keywords associated with the dataset, such as global human settlement layer, we can already see some results popping up, and we are interested in the build-up grid, so we can import it. But before moving forward, let's look at some of the properties of the dataset. So if you click on the data name, you can see the description of the dataset and some associated links if you are interested to read more about it, and more importantly, information about the resolution, bands. So we are interested in the multi-temporal build-up presence band, and also some class values. So here we can see the values that are higher than 3 represent the build-up area in different epochs. So for the ease of use, let's rename the layer as dataset. Okay, so now we have it. And here we can see the keyword image next to the dataset. In Earth Engine in general, raster data are represented as Earth Engine image objects. Each image can have one or several bands, and each band can have their own properties. To view these properties, we can use the print function. And when we click on Run button, we can see more information about the dataset, so the unique ID that could be also used for importing the data, the band information, and also the specific information for each band. So now let's find the and visualize the data representing build-up area. So for that we need a new variable, and which we can name as build-up, which is equal to, we have to use our dataset, and we have to select the build-up band. For that we will use select, and we put the keyword build. Furthermore, we could have stopped here, but in order to select the pixels with the values higher than 3, in order to only have visualized the data of the build-up area, we can use the method greater than and equal, and we can use the value of 3. So here we will pick the values which are greater or equal than 3. And what's left is only mapping. So we will use map add layer. So it takes some time to print the values. And as mentioned, it's a global product, so it can be visualized for specific areas. We can zoom in for much more details. So here with the inspector tool, you can also click and get the information for the value for specific location. So we can have 1 for built up and 0 where there is no build up detected. So now let's make a small change and look at not the values which are greater than equal 3, but look at the data for a specific epoch. Here we have to change just from greater than equal to just equal to 3. So this is the latest epoch, and when we click run again, we will see how instantly the visualization changed. So here we have only the values where it was built up for that specific epoch. So this is all for the first practical, and we will move to the next user case now.